Hello, my name is Catherine Forrest, and I'm a undergraduate senior in the iSchool, and I'm also a newly admitted fast track master's student. Today, I will be presenting on my research project funded by the Syracuse University source on blockchaining the MEWPUL digital twin. So in May of 2020, Syracuse University, the State University of New York, College of Environmental Science and Forestry, and the State University of New York Upstate Medical University innovated the ultra sucrose method for real-time transmission tracking of COVID-19. This innovative testing solution is scalable and deployable through the mobile early warning platform Ultra Sucrose Lab, also known as the MEWPUL. My objective was to create a MEWPUL digital twin using Azure, Microsoft Azure, to optimize design and manufacturing processes, maintain physical assets, and provide data analysis mechanisms for proactive maintenance. Digital twins are a great way to model the MEWPUL, however, they have some access control security issues. So the question was, how do you blockchain the Azure digital twin of the MEWPUL in order to solve their inherent access control security issues? I'm going to pass it over to my mentor and Professor Lee McKnight, who's going to tell us a little bit about the MEWPUL.
Thanks, Catherine. So this slide was developed in April 2020 and refined by May 2020 to describe this. Well, obviously, we all know what a crisis this pandemic is and was at that time. So developing a modular standardized method for collecting data on COVID-19 in wastewater, analyzing it, classifying it, and then aggregating and relaying it. That's life and death stuff. So that technology, within a couple months of its invention, was being planned for use and deployment in within weeks of deployment and use in upstate New York counties and in Syracuse University dorms and other areas throughout New York State in cooperation with the New York State Department of Public Health. So if we have this method that is quickly becoming standardized, we think, what if you could actually make it portable? If you didn't have access to the right professors in upstate New York or the right lab doing the analysis, the rest of the world could use some standardized methods quickly. So we quickly envisioned imagining putting this into a freight container and making it portable. We were in dialogue with the various parts of the Department of Defense in particular, but DoD doesn't usually get things out the door as quickly as a pandemic, but we did develop the conceptual framework for having a lab doing the standardized method on a ship, having a different version of it, going to any smart base, having it basically deployable in any emergency humanitarian situation. And so if you have this thing, but we haven't actually built one yet, but it's easy to configure and imagine because we know the process here, couldn't we just start working on a digital twin? And now back to Catherine.
Thank you so much, Professor McKnight. So Praveen did a great job of introducing us to digital twins, but I'm just going to quickly go back over it. So a digital twin is a digital replica of a physical object or process designed to understand, control, simulate, analyze, and improve operations. Digital twins bridge the gap between the digital world and the physical world. They function in the digital realm just as they do in the physical. The creation of the MEWPUL digital twin utilizing the Azure digital twin platform will serve to optimize design and manufacturing processes, maintain physical assets, and provide data analysis mechanisms for proactive maintenance. Although digital twins seem to be the perfect modeling solution for the MEWPUL, there are several access control security issues with them. So traditional digital twin development relies on centralized authorities to define truth. However, this does not ensure integrity. There are also the critical issues of interoperability among collaborators on the network, the security and integrity of stored data and analysis, and communication transparency between peers on the network. So our blockchain solution, or the blockchain solution that I developed, utilizes consensus quorum, which is an open source protocol layer which enables users to leverage Ethereum for private and public blockchain DApp, which is decentralized application, and smart contract development. So consensus quorum is a box, and then inside that box we have a smaller box, and that's Hyperledger Bisu, which is distributed ledger software. So Hyperledger Bisu is an open source Ethereum client that enables us to implement our security mechanisms. But before I go into that, a client is essentially a software application that lets us utilize certain specifications on the Ethereum network, and clients can also collaborate and communicate with other collaborators on the network. So Hyperledger Bisu enables us to implement our security mechanisms, IBFT, which is IBFT 2.0, which is Istanbul Byzantine fault tolerant, an example of proof of authority, consensus protocol, and on-chain permissioning. So blockchain is a security solution for distributed networks where we don't know who the peers are on the network or if they're trustworthy or not. It's not centralized, so the peers are who govern the network. So the goal is to ensure integrity on the network, and this is done by utilizing consensus. So a lot of you may have heard of proof of work, where the peers on the network are miners, and these miners are competing to solve complex hash equations. The first to successfully solve the complex hash equation and verifying transaction gets a reward. Proof of stake is where peers on the network, the peers on the network are known as stakeholders. They hold the proof of stake cryptocurrency. And what they do is they're essentially gambling their cryptocurrency. They're saying, I'm going to risk this amount of my this proof of stake cryptocurrency for this transaction to go through. Now, if the transaction goes through, those proof of stake holders get a reward, which is, shocker, more cryptocurrency. However, if let's say someone on the network is trying to do something malicious and that transaction is, not truthful. So if that happens and the transaction is not verified, it gets slashed and the crypto is gone forever. So IBFT, Istanbul Byzantine fault tolerance, is an example of proof of authority. And so so Istanbul Byzantine fault tolerance is a consensus algorithm derived from the logical dilemma called the Byzantine generals problem. So I'm just going to quickly go over what this is. So the Byzantine generals problem is when there are multiple generals and they're surrounding a city in which they're going to attack. Now they either have to decide to attack said city or retreat from it. Now, it doesn't matter if they attack or retreat, it just matters if they come to a consensus. Obviously, there would be a failure if two of these generals go in, other two don't go in. It's not looking too good for those guys. So, and the issue inside that is that there are communication issues. So these generals cannot communicate with each other directly. They are connecting or can talk to each other one at a time and through a messenger. And the messages could somehow get delayed, destroyed, or lost, or a fraudulent message could, get sent out by one of the generals to confuse someone for, some malicious way. So if we apply this dilemma to Istanbul Byzantine fault tolerant, this is when our generals are validators on the network, and these validators work together to vote to consensus. So Istanbul Byzantine fault tolerance is the ability for a blockchain network to operate accordingly and to reach this consensus despite the chance of nodes failing or propagating incorrect information. With Istanbul Byzantine fault tolerance 2.0, it requires a total of 4 validators on the network to validate the transaction. So for a block to be inserted on the chain for that which is validating the transaction, there needs to be greater than 66% of validators must sign the first block. For a validator to be added or removed from the blockchain, there has to be a majority vote greater than 50%. Proof of authority consensus protocols have faster block times, much greater transaction throughput, and immediate finality. It's ideal for consortium blockchain network. Consortium meaning with the MEWPUL digital twin, like we saw on a couple of slides before, is that we would be working with organizations, government organizations, CENTCOM, and so they could be able to access this network with other organizations. So proof of authority is really built for, it's really a solution built for consortium network, which is perfectly fit for the MEWPUL. We will also be exploring implementing on-chain permissioning. So Hyperledger Bisu gives us the I can't. Gives us the opportunity to implement on-chain permissioning, which utilizes smart contracts to store and administer node account and admin allow lists. Allow lists is exactly what it sounds like, a list that allows certain people to do something. So using on-chain permissioning enables all nodes to read allow lists from a single source on the blockchain. Permissioning implements three different types of allow lists: accounts, which can submit transactions on the network; nodes, which can join the network; and admins, who are accounts that are able to update accounts on the network and node allow lists. And so now I'm going to go into some implementation challenges that I faced during my research. So there's really very limited resources out online. Growing up with the internet, it's pretty scary to see when you go and Google search something and nothing pops up. And that's what happened when I looked up blockchaining a digital twin. There are several people currently in the process of working on this cutting edge solution right now. People out in Germany, people in the Middle East. And so it's really just this cutting edge technology, which has made it definitely a challenge. And then, so there are also no off the shelf capabilities. So, Azure doesn't provide a digital twin blockchaining service, right? They're collaborating with Consensus, and Consensus is enabling them to utilize their technology. So, we can build out that solution, but there's nobody has done this before with Azure and with Consensus. Another challenge was securing resources to execute the solution. We weren't able to secure the Azure Digital Twin service during this 3 month grant, and this is. But I utilized open source solutions and working with Azure and getting Azure certified. So we've been able to access some resources, but not the literal service. It's really expensive, and yeah. And so another challenge is building a constituency within the university that understands the value of funding this project. So by doing this, building a constituency, we can raise awareness and get the funding that this project needs to be executed. That's all. Thank you so much for your time. And I'm excited to hear the rest of the presenters.